This video, we are going to focus on vectors. So what is a vector? A vector is a quantity that has both a magnitude and a direction. When we draw a vector, we're going to represent it by an arrow. It's going to look something like this. And when we talk about what the name of the vector is, let's say I'm calling this vector V, where you're going to see this notation with a little arrow over it. We're going to use lowercase letters and an arrow over it to indicate that we're talking about a vector. The length of the vector, so how long it is from here to here, where this is the initial side, or the initial point, and then it ends here, so we call that the terminal point. That length we also call magnitude. And then the arrowhead indicates the direction. So in this case, the arrow is going from left to right. So we would say the vector is going from left to right. If we had something like this, I'll call this vector U. We would say it's going in a northwest position. So it's starting here at the initial, and then it's ending here at the terminal point. The zero vector is a pretty special vector. We know we're talking about the vector because of the little arrow above that vector. It has a magnitude of 0, and the 0 vector is not going to have any kind of direction. And once we start talking about parallel and perpendicular vectors or orthogonal vectors, we're going to see that the 0 vector is both parallel and orthogonal. We'll see that in the next section. So two vectors are equal if they have the same magnitude and direction. So if they're going in the same way, same direction. And then we're going to talk about geometrically adding, and then we're going to look at doing things algebraically. So when we add vectors geometrically, so we're going to actually have pictures here of vectors. We add them tip to tail. So if we want to add vector v plus vector w, we're going to start with vector v, and then we're going to pick w up, and we're going to place it at the end of vector v. And the vector v plus w starts where v starts and ends where w ends. So let's look at an example. So I've got some vectors down here, a u vector and a v vector. So this u vector is starting at the point 26, and it ends at the point 58. V is starting here at 9, 11, and it ends at 7, 12. So if I wanted to add these vectors, let's say I want to find u plus v, whatever that vector is. So I'm going to start with u here. V is going to start here where u ends. And notice to get from this point, the beginning of V to the end of V, I'm going to move to the left 2 and up 1. So I'm going to do the same thing here, to the left 2 and up 1. And there's my V. I've literally just picked it up and I've moved it somewhere else. So then the vector U starts where U starts and end where V ends. So this is U plus V. And that's what that vector would look like. If we wanted to graph something like negative V, we could. Negative V just means it's moving in the opposite direction. So instead of going left 2 and up 1, we're going to go right 2 and down 1. So this is what negative V would look like. Now, notice that with these vectors, they're not starting at the origin. We could create what's called a position vector. By picking those vectors up and moving them to the origin. And a position vector, to how to find it, is we take the terminal point and we're going to subtract the initial point. And that's going to give us a vector that's going in the same direction as the original vector, but it's going to start at the origin. So let's do that with vector u. So vector u started at 2, 6, and it ended at 5, 8. So the position vector for U would be terminal minus initial. And once we start talking about position vectors, we're going to see it written in these brackets with greater than and less than signs. Is what it looks like. So terminal minus initial. So we're going to have 5 minus 2 for that first coordinate, and then 8 minus 6 for the second coordinate. So terminal point minus the initial, terminal minus initial. And I'm going to simplify that. 5 minus 2 is 3, 8 minus 6 is 2. So this red vector here, vector U, if we were to pick it up and place it at the origin, which would be here, we're going to move 3 over and up 2. And there is my position vector. And you can see it's going in the same direction as U. It's the same length as U. It looks identical to U. The only difference is the placement on the Cartesian plane is starting at the origin. And we could do the same thing for V. It's going to be terminal minus initial. So terminal minus initial, 7 minus 9. Terminal minus initial, 12 minus 11. So vector V as a position vector is going to be at -2, 1. That's where the end placement's going to be, -2, 1, right here. And if I were to draw that, that is my V vector as a position vector. And you can see lines up with what the blue is. To get from the beginning to the end, we moved left 2 and up 1. Left 2 and up 1. That's what that's telling you, is how to move along there. So let's look at some properties of vectors. Vector addition is commutative. What that means is that I can add them in any order. So I could take vector U plus vector V, and I can add vector V plus vector U to it. I'm going to get the same vector either way. And we could see that down here. So here's U plus V. If I did it the other way and I did V plus U, and let me move V. Well, let me just do it here. So V plus U. If I were to add U to this vector V, let me do it a different color. U is going to move 1, 2, 3 units to the right and up 2. So here's vector V. If I move 3 to the right and up 2, I would end up with this. So V plus U. Let me erase this guy. Would start where V starts and end where V ends. So this is V plus U. And so you can see, to get from here to here, I would move right 1 and up 3. Same thing here. I move right 1 and up 3. So you can see how this vector and this vector are identical to each other. That's because the addition order doesn't matter. I'm going to get the same thing either way. Associative. Associative is about parentheses, so groupings. What that says, if I add U plus V plus W, order of operations says I would have to add V plus W first. That's the same thing if I change the order U plus V plus W. The zero vector, if I take any vector and I add the zero vector to it, I'm going to get the vector V back. If I take a vector V plus its negative, I'm going to get 0. And if I want to subtract vectors, I can actually think about adding the negative. When we talk about a scalar value, we're talking about a quantity that only has a magnitude. So a scalar is really just a number. Magnitude. When we see this kind of notation, it's a double absolute value, that bar. That means that we're talking about the magnitude of v. Magnitude is length, so we're talking about how long it is. So what are some properties of magnitude? Because we're talking about a length, the magnitude has to be greater than or equal to 0. The only way that we could get 0 for a magnitude is if we're talking about the 0 vector. If we have two vectors that are going in opposite directions, but they're the same vector, the length of vector v is going to be the same as the length of its negative. And then if we are multiplying a scalar value, so think a number times vector v, then we could think about taking the absolute value of that number times the absolute value, times the magnitude of v, and this would give us the same length as if we were to multiply the scalar through and then find the magnitude. We're also going to see something about unit vectors. A unit vector is a vector that has a length of 1. And we can take any vector and convert it to a unit vector, and we'll see that later within the next couple of sections. And then we've talked about that numeric way or that algebraic way of expressing a vector. And we talked about the position vector, how to find a position vector. So let's look at some examples. How do we add and subtract vectors algebraically? Well, it works the same as if we were just adding and subtracting regular vectors. Let's say we have vector v, and that's the vector 3, -5. And we have vector u, and that's the same. Maybe that's vector is 2, -1. Because of the notation that we see here, this is this means that we're talking about position vectors. So let's say we want to add these numerically, v plus u. All that means is we're adding like components. I'm going to take 3 plus 2 to get the first component. I'm going to take -5 plus -1 to get the second component. And you can see that if we were to add that in any way, we're going to get the same thing. 2 plus 3 is still 5. -1 plus -5 is a -6. What if we wanted 4 times vector v? Okay, that means that we're going to multiply the scalar through every number in v. So 4 times 3 is 12. 4 times -5 is -20. And then let's say we wanted 2u minus v. So I'm going to start by finding 2u. So 2 times u is going to be 2 times 2, 2 times -1. And then I'm going to subtract vector v. So when I simplify this, 4 minus 3, -2 minus -5, there's my vector. Now, we can take any vector and we can write it in terms of unit vectors called I and j. I is moving one unit along the x. J is a unit vector that moves along the y. So if I wanted to write vector v in terms of I and j, I could think about this as 3i minus 5j. Okay, and that works because I is the vector 0, 1, and j is the vector, I is the vector 1, 0, j is the vector 0, 1. And you can see if we were to multiply this through, we're going to get 3 and -5 back. And we could do that for any vector, express it in terms of I and j. So u, if we wanted to do that, it would be 2i minus j.